Okay, today we're going to look at the other acceleration formulas. We looked at the first one already. So yesterday we looked at the basic acceleration, where we just do the change in velocity over time. So that formula will be used often, and remember, we can solve it for other things. We could find the time or the final velocity or the initial, not always just the acceleration. The first velocity formula we did, we're not going to worry about for now. So basically we're looking at yesterday's acceleration formula plus the other four that are on your formula sheet here. So what are the differences between these formulas? Nothing. All five of these formulas are all exactly the same. There's just different variations. So if we took the first formula and substituted distance over time in for velocity, and we do some rearranging, we might get one of these other formulas. If we used graphs and combine different things and so on. So basically all five of these formulas are acceleration formulas, and the only difference between them is it depends on what information you have in the question and what information you're looking for. The key thing to remember with each of them is to sort of look at the formulas by themselves and figure out what's missing. So we have five variables. We have acceleration, we have initial velocity, final velocity, distance, and time. So there's five different things that we could be finding for any of these formulas. Each of the formulas has four of the five listed. So if you look at each of these, you can see so if you look at each of these, the first one is missing the distance, right? We have acceleration, final velocity, initial velocity, and time, so there's no distance for that one. Okay, the second one below it, you can see we have distance, initial, time, acceleration, we have everything but VF. So that one's sort of our VF formula if it's missing VF. And the next one over, you can see we have everything but VI. So those two, these last two, are sort of the same. The bottom one, you can see the formulas are exactly the same, just one is VF, one is VI, and then the only difference is one's a plus, one's a minus. The one below it, you can see, has everything in it but acceleration, and the very bottom one has everything except for time. So when you're doing any of these word problems, the best bet is to sort of label all your information, what you know, what you're looking for, and then try to figure out which one's missing to help you figure out which formula to use. So what we'll do is we'll go through an example using each formula, and then that should be it. So the first example I have is we have a car traveling at 200 meters, so it covers 200 meter distance. So it's a good idea to sort of make a little list. So we have 200 meters for distance. We have an initial velocity of 15, so it says it increases from 15 to 20. So our initial velocity is 15. Our final velocity is 20. And the question is saying, what is the car's acceleration? Okay. So if you look at all of this, everything's in meters per second, so that's good. We don't have to worry about any conversions. Our velocity we'll assume it's just going forward, so we don't have to worry about any negatives. So everything's good there. So now all we have to do is figure out which formula to use. So if you look at the variables we have listed here, we have D, VI, VF. We're looking for A. We don't have time, right? Time is the only one that's not listed there. So if we go back to our formulas, we want the formula that doesn't have time, which would be that bottom one. Okay, so that's the formula we're going to be using. So I'll rewrite it here so we can see it. So we have VF squared equals VI squared plus 2AD. Okay, so now at this point you've got a choice. We're looking to solve for acceleration, so we could rearrange the formula to make it A equals. So I'm going to do that first, just to kind of show you how we could do it. So we would subtract the VI from both sides, so you'd end up getting, so we're going to minus the VI squared. Okay, so we'd end up getting VF squared minus VI squared equals 2AD. And then the last step is we want to get rid of the 2D, so we could divide by 2D. So our rearranged formula then would be VF squared minus VI squared divided by 2D equals A. Okay, some people have tough time rearranging formulas, but I just want to show you that it will work. So let's plug the numbers into this new formula to see what we get. So we'd have VF squared, so that's 20 squared, minus VI squared is 15, and on the bottom we'd have 2 times 200, and that will equal our acceleration. Okay, so plug that in on your calculator. So 220 squared plus 15 squared, hit equals, divided by brackets. So it's a good idea to put the brackets around the whole bottom. 2 times 200, end brackets, hit equals. We get an answer of 1.5625. But we want to round this to go back to our question. 2 sig digs is our least. So we'll round it to 1.6 to get 2 significant digits. So 1.6 meters per second squared. And we're done that part of the question. Okay, before we go to the second part, I just want to go back to our formula and I want to show you sort of the math way of solving this. And I think most people would actually do the math version instead of rearranging the formula, because sometimes it's tough rearranging the letters to get it done right. So what a lot of people do is just stick with the formula in the way it was given to you. Okay, so let's do the second version. So we'll just plug in all the numbers wherever they would go. So your VF would be 20 squared, your VI is 15 squared, and we'd have 2 times A times 200. Okay, so if you're going to solve it this way, the next step then is just figure out all the numbers. So 20 squared is 400. So just simplify everything into numbers. We'd have 400 equals 15 squared is 225. And then we'd have 2 times A times 200. Let's just go 2 times 200 would be 400. And let's put the A at the end. So now you can see we just have a basic easy math formula to solve. So we'd get rid of the 225 first. So 400 minus 225 equals 175. And that equals 400A. So our last step is divide by 400 on both sides. So when we do that, we get the wrong answer. What did I do wrong? Let me just double check. So we got 20 squared minus 15 squared is 175 divided by 400 equals 0.43. Okay, so I think that is the right answer. So 2 digits, we'll round it to 0.44 meters per second squared. Okay, I think I screwed up on the first version, so let me just go back over to this blue one and redo this calculation. So 20 squared minus 15 squared, hit equals, divided by 400 gives us 0.43. Yeah, so I just did a calculator mistake on this one over here. So we should have had the exact same answer, 0.44. Okay, so you see that no matter whether you rearrange, you can either rearrange the formula and get,
Can I have your attention, please?
so you could rearrange the formula to get 0.44, or just plug in the numbers and then rearrange the math equation. I would say over the years that I've taught this course, most students end up picking the second version. They find that easier to just plug in the numbers, leave the equation the way it is, plug in the numbers, simplify all the numbers, and then just solve the equation using those numbers. Okay, that's the first part of the equation. Let's look at how to solve the second part. So the second part was the exact same information, but now it's asking how long did it take. So we could, now that we just found the acceleration, we could now use basically any of the other formulas we want to get the time, but it's a good practice. So we could use any of the formulas now that we have the acceleration, but it's a good practice to get into when you're doing physics to try not to use any calculated answers, just in case you had the wrong answer. So if you look to the previous example, my first answer was wrong. If I would then use that acceleration to answer something else, obviously I'm going to get that question wrong too. So if you can, it's always best to stick with the information and just go with the numbers that they gave you. So for this one, we have our 200, our 15, and our 20, but now let's solve it for time. So we'd have the exact same information, but we want time instead. So same thing, we go back to our formulas. Which formula has time now, but not acceleration? And that would be the middle one over there. So we have VF, VI, T, and D. We're solving it for T. We have nothing about acceleration, so that should work. So let's write that formula in there. So we have D equals VF plus VI over 2 times time. Okay, so there's the formula we want. Let's do it the math way. So let's just plug in all our numbers. So we'd have 200 equals 20 plus 15 divided by 2 times time. So we can do all the math on the one side there. So 20 plus 15 is 35. Divide that by 2, we get 17.5. Times time. So our very last step then is we just want to divide by 17.5. So divide both sides by that. So 200 divided by 17.5. Our final answer we get is 11.428. And just like the previous question, we just want 2 sig digs. So we'd round it off to just 11. So 11 seconds would be our final answer. Okay, so you can see with these two examples, just take the information, figure out what you're looking for, figure out which part of the 5 variables you don't have. That'll help you to figure out which equation to use, plug the numbers in, and solve. Let's do a different one. So now this is a different question. It says, how far does a car travel backwards if it moves from stop to 5 meters per second in reverse over a time of 12 seconds? So let's figure out all our information here. So our stop would be our initial velocity, right? It was stopped. Our final velocity is 5, but it's in reverse, so remember that's going to have to be a negative. We have our time of 12 seconds, and the question was asking how far, so we're looking for our distance or displacement. So this is a different way some people like to do the question. So we have D, T, VI, VF. We don't have our acceleration, so you can see it's going to be exactly the same formula that we just did. We would have the D equals VF minus VI. So we'd have VF minus VI divided by 2 times time would be our formula we want to use. Let's plug in all our numbers. So in this case we're looking for D, so that's good. We don't have to do any rearranging. So our VF would be minus 5. Our VI is 0. So that's good. Divided by 2 times 12. So just plug all those in on your calculator. So you'd have negative 5 divided by 2 times 12. We get an answer of negative 30. And we want 2 digits. So that's good. So our final answer then should be negative 30 meters. Does it make sense that our distance negative? Sure. The car was traveling backwards, so from where we started, we're going to be going backwards 30 meters in this case. So you can see as long as you plug the numbers in correctly in the formula, whether they're positive, negative, or whatever, the answer will take care of itself. You don't have to worry about directions and things like that. Okay, let's try one more. So this one we have an airplane, it's going 500 kilometers, so we have a distance of 500, but we have 500 kilometers, so we got to be careful. Remember, when we're dealing with these, we want it to be in meters per second normally. So we have kilometers, minutes, meters per second, we got all kinds of units going on in this question, so Let's change those right off the bat. So 500 kilometers will be 500,000 meters. So we would add three zeros on. And then our time is 45 minutes. So we don't want minutes, we want seconds. So we'll times 45 by 60, and that gives us 2,700 seconds. Okay, so those are good. And we have an acceleration of 2 meters per second, so that's good. So the question is, what is VF? Okay, so if you look at all the stuff here, we have everything we need except for VI, so we want the formula that doesn't have VI. So if we go back to our sheet, the formula with no VI is that top one on the right. So that's going to be the formula we're going to use. Okay, so without the VI, the formula we want is the top one, so VFT minus 1/2 AT squared. So that once again, let's plug in just the numbers. So we'll have 500,000 for our distance. Our VF is what we're looking for. Our time is 2,700 minus 1/2 times 2 times 2,700 squared. Okay, big numbers, but it should work the exact same. So now let's simplify all the math. So we have 500,000 on this side equals 2,700 VF minus 1/2 times 2 times 2,700 squared is 7,290,000. Okay, so just like we do other math formulas, let's add the 7,290,000 over to the other side. Okay, so we'll do that plus the 500,000. And we get an answer of 7790,000. That equals 2,700 VF. So then our last step is just divide by 2,700. And we get an answer of, what did we do wrong? There's something wrong. Just hang on one sec. Okay, I double checked the math. Everything is good. It's just that we're getting an answer that really doesn't make sense. So I just made a mistake when I made the initial number. So instead of changing anything, we'll just leave it as is. So our final answer I got here was 2,885, which is right answer, but it's just too big of a speed for the context of the question. So I messed up somewhere when I wrote down the question, so we'll just leave it at that. So 2,885 would be our correct answer, and that would be in meters per second, which is super big, but that's okay. We'll just leave it for now. And obviously we'd want to round it off to 2 sig dig, so we'd put it as 2.9 times 10 to the 3. But because this is a bad question, we'll just leave it there. Okay, one more example. So this one, we have a car that goes from rest to a speed of 40 kilometers per hour over 100 meters. The question is, how long is that going to take? So let's do our variables again. So we have a distance of 100. Our initial velocity, it says it's at rest, so we got 0. And we have a final velocity of 40. But remember, that's in kilometers per hour, so we want to change that to meters per second. So on your calculator, divide by 3.6, and we get 11.111 repeating. So make sure you keep all those decimals when you do your calculation so that it's as accurate as it can take. And the question is, what is the time? And that's it. So this formula, we have no acceleration. So if you looked at our formulas, you would use the same one we did earlier, but I'm actually going to change the question because we already did one like this. Let's actually change the question so that we would okay, I'm going to stop and I'm going to fix it, so hold on. Okay, so I just switched this question, so instead of having a VF, I changed it to an acceleration of 4. We're still looking for the time. So we have distance, initial velocity of 0, acceleration of 4. What is our time? So if we go back to the formula page, the formula that doesn't have final velocity is VIT plus 1/2 AT squared. So that'll be the one we pick. Plug in all of our numbers. So we'd have 100 equals, our VI is 0, so we have 0 times time, which 0 times anything is 0, so we can basically just ignore that part of the equation. So we just have 100 equals 1/2 times 4 times t squared. So if we do the math on that, we'd have 100 equals 2t squared. Divide by 2 on both sides. So we'd have 50 equals t squared. So our last step then is we just want time, so we're going to square root 50, and we get an answer of 7.07. We're going to round it off to 2 digits, so we'd have 7.1 seconds. Okay, so that's it. It shows you the other example. I won't bother looking at the first formula. We did lots of those yesterday, so this just shows you an example or two of each of the other formulas. And that's it.